and I want to welcome you to MyChem Tutorials. And in today's video, we're going to be talking about using numerical method to find the limit of a function. So example 1, find the limit as x approaches 1 of x squared minus 1 all divided by x minus 1, where x is not equal to 1. The reason being that when x is equal to 1, the denominator is 0. So these are more like the exception, as in the domain, the x, the denominator can't be 1, right? Good. So now let's get right into the video. To find the limit of a function using the numerical method, you have to first of all find test values. And when we say test values are values that you are going to plot or substitute into the function to know the behavior of the function. To get your test values, let's begin with the solution for this word, solution. First of all, x is approaching 1. It means that we're going to draw our number line, and when we draw our number line, we know that this is 1. Then on the right hand side of 1 will be 2, on the left hand side of 1 will be 0 on the number line. So we are going to look for numbers that are approaching 1 from the right hand side. Then we are going to also look for numbers that are approaching 1 from the left hand side. So here is the left hand side, this is the right hand side. So how are we going to pick the numbers? To pick the numbers, the idea is that look for numbers that are close to 1, but they are not 1. And note, the numbers that are at the left-hand side of a number are always less than the number. And numbers that are at the right-hand side of a number are always greater than that number. So we're going to look for test values. On the left-hand side, if you look carefully, what number is closer to 1 on the left-hand side, but it is not yet 1? The perfect number would be 0.9. You can see that 0.9 is less than 1, but it is almost like 1. It is about to become 1, right? So 0.99 also is a number that is at the left hand side and is approaching 1. 0.999, 0.9999. They are all numbers approaching 1 from the left hand side. Remember, left hand side values are less than the number, right? And they are approaching the number, as in this case 1. Also, when we do same to the right hand side, which number is greater than 1 but it is approaching 1, it is becoming 1? That is when we pick 1.01, right? It is greater than 1 but it is almost like 1. Then 1.001, 1.0001, 1.00001. All these numbers are approaching 1. Right? On the right hand side, it is going to be values that are approaching 1 but are a bit greater than 1. On the left hand side, they are going to be values that are less than 1 but it is approaching 1, right? Probably you might still not be okay with how to pick the test value. So let me give you an example. Let's say that we are having another normal line, but this time our x is approaching 2. You get it? An example, our x is approaching 2. How are we going to pick test values? Don't worry, just come to your number line. X is approaching 2, so we write our 2. Then we ask ourselves, on the number line at the right hand side, which number are we having? Remember, on the number line we have 2 and 3, right? So 3. Then before we come to 2, we would have come to 1, so 1, 2, 3 in that order. Then we ask ourselves this question. This is the left hand side, and remember I communicated earlier that left hand side numbers are less than this number and right hand side numbers are greater than that same number. So if I'm going to pick a number that is closer to 2, it is almost like 2 but it is at the left hand side, there are two things you have to put in mind. The number is going to be less than 1 and the number will almost be 1. Sorry, the number is going to be less than 2, then the number will almost be 2. In that case, then the perfect value is going to be 1.9. You see, it is less than 2, but it is almost 2 when rounded up. So the next one is going to be 1.99. The next one is going to be 1.999. The next one is going to be 1.999 and 9. And if we are picking values on the right hand side, they are greater than 2, but they are almost 2. I want you to pause the video and think about it. So those numbers are 2.01. You can see 2.01 is greater than 2, but it is approaching to almost 2. So 2.001, 2.0001, 2.00001. I hope the understanding of you being able to pick a test value is clear using the number line approach. Okay, so let's get right into the question we were solving before. So I'm going to clean this. In order for us to find the answer to the question, after finding our test value, the next thing that we're going to do is to draw a table. We're going to draw a table, and this is what we call the numeric table. So we draw a table, right? And after drawing the table, we're going to mark here. Then we divide it into 2. We divide it into 2. So we're going to divide the table into 2. Then we write on top of it, let me write slightly. We write on top of it the left hand side. So this becomes the left hand side. Then this becomes the right hand side, right? Then we'll divide it again into 2. We divide it again. This becomes our x. This becomes our f of x. This also becomes our x. This becomes our f of x, right? So we have to divide it. We divide it. I hope it is clear. Now this is what we are going to do. We are going to put our test values into this table. So our first input on the left hand side is 0.9, right? So we write here 0.9. Our next input is 0.99. So we continue inputting. Our next input is 0.999. And our next input again is 0.999 and 9. I hope it is clear. Then we continue again. On the right hand side, let's make our input. This is our first input. So we put it on the table. So our first input is 1.01. Our next input is 1.001. Then we have 1.0001. We have 1.00001. You get it? And this is what we are going to do. You see that the next column is f of x. So how do we do the f of x? To do the f of x, when you pick your calculator, you punch bracket squared minus 1 divided by bracket minus 1. And all that you're going to be doing is that you're going to be inputting the test values, right? So the test values is f of the test values, and these are what we are going to put inside. So our first input is going to be we put in 0.9 in here to see what we're going to get. I hope that is clear. So that is the test value. So we are going to put that on the calculator so that we can get f of the test values, right? So 0.9, you put it in a function, and when we put 0.9 in the function, we're going to have 1.9 as our answer. When we put 0.99 in the function, we're going to get 1.99. When we put 0.999, we're going to get 1.999. When we put 0.999, we're going to get 1.9999. So one thing is clear, that when the value is approaching 1, right, you can see that it is becoming 1.99999, and as we continue to increase the number of 9 at the decimal side, the value also approaches what? 2. You can clearly see that, right? So we've seen that on the left hand side, the more we get closer and closer to 1, the more the function also approaches 2. I hope that is clear. Then when we do the same input for the right hand side, 1.01 is going to give us 2.01. 1.001 is going to give us 2.001. 1.0001 is going to give us 2.0001. 1.00001 is going to give us 2.00001. What does this communicate? That the more the function also approaches 1 from the right hand side, the function also approaches a 2. I hope that is clear. So how are we going to conclude on this? This is what we're going to write, that from the numeric table, right, the limit as x approaches 1 from the right hand side of x squared minus 1 divided by x minus 1 is equal to 2, and the limit as x approaches the left-hand side of x squared minus 1 all over x minus 1 is also equal to 2. So we say that since a limit as x approaches 1 from the right-hand side of the function f of x is the same as the limit as x approaches 1 of the left-hand side of f of x, because they are all given as a 2, then the limit as x approaches 1 of the function itself is also going to approach 2. I hope that is clear. So this is how we find the limit of a function using the numeric table. I hope I've made it clear enough. So whenever you are being asked in your examination, find the limit of a function using the numeric table. This is what is required of you to do, right? And again, this type of method of solving the limit of a function can be used to solve every limit question, right? It can be used to solve every limit question. So let's continue to solve another question, then we will close for today. Say g of x is equal to sine x out of x. Then the question says that find limit as x approaches 0 of sine of x all over x. How are we going to solve this? Using the numeric method. Using the numeric method, then comma x cannot be 0, because when the denominator is 0, it makes the function to be math error, right? So it's a condition. Good. So to solve this, as I already communicated, you have to find the test values by drawing the normal line, and we draw the normal line using the number x is approaching. So in our case, we're going to use 0. But pay attention to these details. Sine is a trigonometry ratio, which means that it either uses degree or it uses rad. Rad simply means that your input is real numbers, right? And deg, D-E-G, it means your input into the sine function or the trig function is a degree. But since we are using real numbers, right, you're going to change your calculator from the degree mode to the radian mode. You get it? Radian mode recognizes 1 as a natural number, but the degree mode recognizes 1 as 1 degree. So in this work, or for this particular work, you change your calculator to radian, because we are using real numbers as our input, not degree, right? So when we move to the right hand side of 0, we have 1. The left hand side of 0, we're going to have -1. Now we'll pick our test values. So when x is approaching 0 from the left hand side, and this is when x is approaching 0 from the right hand side. So from the left hand side, a number that is approaching 0 but it is not yet 0, it is going to be -0 points, right? 1 is approaching 0, is approaching 0, but it is not yet 0. So -0 points 0, 1, right? -0.0001, -0.00001. These numbers are approaching 0. The more the 0, the faster it approaches 0, and it is from the left hand side. Then from the right hand side, we get to know that 0.1 and 0.01 and 0.001, 0.0001, right? 0.00001. All these numbers are approaching 0, both from the left hand side and the right hand side. You see that before 0, the numbers there are less than 0 and they are negative, right? So what is the next method? The next method is that we're going to draw a table for them. We're going to draw a table. So to draw a table, as we've already learned, we draw a table to input the values to check how the function is changing. I hope that is clear. So the next thing we're going to do is that we write this, then we divide this into 2. divide this into 2, then we write on top left hand side and right hand side. Then after that we divide it into 2 again. After dividing it into 2, what are we going to write? We're going to write that this is x and this is f of x. This is f of x, this is x, then this is f of x, right? Then all that we're going to do is to input the test values. So on the left hand side we have negative 0.1, then here we have 0.1, we have negative 0.01, 0.01, we underline, we have here negative 0.001, 0.001, we continue, we have negative 0.0001, then have 0.0001, right? Then we check the answers of the functions. How do we check the answers of the functions? On our calculator, we have to point sine brackets open divided by brackets open. Then all that we are going to put in here are the values of our test value, right, to get to know f of x. So when we do our first input, we're going to get 0.99, then others follows. When we do our second input, we're going to get 0.99998, right? And others follows. Our third input is going to give us 0.999983. Then the rest follows. So the more we are increasing the zeros and it is approaching a 0, you get to know that the function will also be approaching the number 1, right? And when we do same to the right hand side, we're going to get 0.99. In the first one, we have 0.9998 in the second one, then we have then 0.99998, then it continues, and as it continues, the function is going to approach 1. So what are we going to say? We say that from the numeric table, limit as x approaches 0 from the right hand side of sine of x divided by x approaches 1, and limit as x approaches 0 from the left hand side of sine of x divided by x also approaches 1. Then we say since limit as x approaches 0 of the function g of x is the same as limit as x approaches 0 of the left hand side of g of x, and they are all equal to 1, then we conclude that then the limit as x approaches 0 of sine x divided by x itself is equal to 1. And this is one of the important rule as far as limits and trigonometry is concerned. So this is where we bring the video to an end, how to find the limit of a function using the numeric method. And I hope to see you in my next video. Do well to share this video, to like, to subscribe, and to recommend it to a friend. See you in my next video.